So now PHM, we have seen the PHM methodologies in previous lecture. Now, as I was mentioning, AI or artificial intelligence is at the core of PHM, or as the first line says, AI ML enabled reliability assurance. So it has a role, and we will be discussing it all through our this lecture on PHM as and when the need arises. Because artificial intelligence has a AI as a subject, it has got machine learning, deep learning, and there are various statistical techniques which are interfacing with the AI in various ways. We will discuss that part. But in this lecture, we will discuss largely artificial intelligence and ANN. So neural network is at the core when we talk about AI, because AI in AI, the deep learning is the one where neural networks, they are operating and predicting the targets, okay, or solutions, whether it could be image processing, whether it could be data classification. So there are many things, you know. So but you see, the AI as a field is inspired from the human cognitive faculties, how they work and all that. We'll see in the next slide. But at present, it is better to see what we mean by artificial intelligence. So that here you can see machine learning is a subset of artificial intelligence, and further deep learning is again another central subset of or important subset of artificial intelligence. Machine learning when we say, it uses many statistical techniques and data filtering, feature extraction, creating a matrix to be used for thing. Slowly we'll get onto the regressions and all. They belong to, actually originally they belong to statistic or probability engineering. And then we have the ANN playing key role here in deep learning. So when we what are the toolbox? I would say the toolbox we have here. First will be, we are in this presentation itself, we'll see the neural network. And of course, it will not be over. It will be coming, and because we are increasing the gradient slowly. So now we will be going into the specific aspect, and then we will be discussing activation function, its role, and supervised learning. So there are three ways of learning: unsupervised, supervised, and three are reinforced learning. So the neural network is there. Then the activation function, what it does there is a support vector machine which is essentially used for classification when we have huge amount of data and certain data characteristics are shared by other data. How we will know that? So that kind of thing made possible by support vector machine. And regression. Regression is among the data points, which data point agree, what is the coefficient of correlation, and all those things. This will be coming in the next presentation. Then gradient descent optimization, genetic algorithm, k nearest neighbor. It is one of the most used and elegant technique. The distance between 2 points that will in a broader way determines that it belongs to a particular group. So it is called k neighbor and reinforced learning. Very powerful technique being used. So before we go to the AI, ML, deep learning, and all those, let us see this artificial intelligence. This field, if we go to the ecosystem in 1980s, it was evolving and it was recognized as one of the important field. But then there were especially on artificial neural network and its application, there were doubts being raised, and there were many observations coming from various corners, from industry, labs and all that, that they are not able to predict um, okay. So, what is the reason? The best of the algorithms that were being used models being used. So, there was a sense prevailing at that point itself that it is the domain knowledge which is very important. If the domain knowledge is weak, it's like something junk in and junk out. They have a correlation. So, if the domain knowledge is not well represented or is not there, only intelligent algorithm alone cannot determine success. And the net effect was that in last 30 years or more, or 40 years I would say, a lot of data, emphasis was on data, and the outcome was that domain experts were realized. Without domain experts, because some PhDs were done around that time, and there the ANN had done a very good job. In fact, in a complex engineering system, it had identified the various situations pretty well, and with a confidence which is synonymous to how a human will have. So, with that confidence, now we are seeing that the data science itself has evolved into one important field, because more than 50% of resources goes into data collection, data lining up, data analysis, and finally processing and feature extraction for the subject that we are handling. So, a lot of credit goes to the data, and that's how we have what AI and ML, we have lot of confidence, and we are having a very good reputation that the artificial intelligence, the field has. Now we have regenerative model, but then again there are some issues are being raised, that what kind of confidence we should have, even though it is pretty attractive and all, whether for security system, for as a social thing, whether it can be used in a way which is harmful and all that. So, I mean, that is something like, so because if you have to keep it in mind, if you develop any application, it's a other side of the scene also, so that it cannot be misused. So, this is something we can stop here at this point of time. It is a very attractive option available in industry and everywhere. Okay. And how we had gone to improve the data quality? It is pre-processing. That means before the ANN was fed some data, it was pre-processed. Noises were reduced, okay, and certain missing data were validated, okay, and outliers were seen and eliminated. So those kind of things were going on, and then feature extraction for every application will require. It is difficult to handle all the data that is coming as it is. So it has to be abstracted. That data feature to be extracted, like mean, median. For vibration, it could be RMS value and peak, whatever coming. Just simple example, in a control room, if you invite a vibration expert and you show him this data, he will say, I can see the two peaks and their distance, and probably it appears to be bearings inner cage failure. So these kind of intimate knowledge should be so that is called feature extraction, okay. And then recall test that we perform, because before the ANN is certified for real time use, enough testing has to be done. So testing is a very rigorous procedures, and a lot of randomness is associated on the prediction. So that kind of thing should happen. And then wherever data is not there, can just say, we have a sensor data, and any deviation can give indication which is sufficient enough for us. So, with that, we came to a conclusion. Net result is artificial neural networks, especially for prognostics and diagnostics, they have a pre-processing of data, feature extraction of data, and the hidden layers, they provide a lot of insight what is happening at the intermediate level of the, like, so we will see in later stages the recurrent neural network, and then CNN, okay, convolution neural network, and many LSTM and all. In next week or so, something we'll see those kind of things. This technology itself is evolving now. So let us see, let's say treat that as a toolbox. So in artificial intelligence, there are two types of training or learning we can call supervised learning. Supervised learning, in short, what it means is you have input data and you have output also with you. Okay, so that means my data, my data which is arranged in this way, and if that kind of pattern is formed, the certain defect or unlikely condition will be condition number 1. If there is a second set, then condition number 2. So that means input output relationship was known actually. Like if I take a numerical problem, I'll say have this x and y and z, then what is the output? But of course here it was complex, there was no linear solution that was available. So I'll take one stage ahead. If these are the trips and alarms and these are the parameter values, this will be carrying offside power failure. So, so this kind of thing cannot be solved by any mathematical equation. So supervised learning was a very handy tool, and it reduces uncertainty in prediction. It can be tested on simulator and all. So that was available. There is something called unsupervised learning. Unsupervised learning, you have a lot of data. Many data might have be sharing characteristic with other data, but how we know that? So that means when their attributes are defined, and then a tool like support vector machine can classify this boundary, and they can say this first data set to a second data set, and they share this boundary. And then it came as a tool. If I assume a parameter, what is its sensitivity, how close it is to the real data. So regression analysis is done. Then genetic algorithm is basically trying to see how, what kind of modeling we do. It is from natural inspiration, how genetics it works, in stages actually. So that will be, and support vector machine, as I mentioned, for unsupervised learning, okay. And then gradient descent method, a change in when we are training or some changes occurs, when it reaches optimum level, how we will know? So gradient descent, gradient will be 0. So at various nodes we have to do that, so that it is can be used, information can be used in training as well as in implementation also. And then KNN, K nearest neighbor. I mean, physical distance itself can tell. It's a very elegant mechanism, as I mentioned. Then reinforced learning, that we'll discuss. There are many things. When we see some application, we'll be discussing with those things. But at present, let us see. So in this lecture, we will be discussing ANN, supervised learning, unsupervised learning, and from regression, we'll go into the next lecture. So let us get the intimate knowledge about the artificial neural network. We have been telling that it is inspired from the connection in the brain, and this is how cognition works. The frontal lobe, it takes the decision. So how between nodes which are neurons here, and then link nerves, they are connecting in brain, and how they can come to a decision over here. This is the nervous system. How about the body? You will know what is what. And then pre-processing of sensor. You have sensors. Your eyes, will give a visual thing. Nose, smell, ear, vision, audio, and this kind of vision is with optical thing. So the vision, your eyes, this information goes and it reflects. So occipital lobe, it goes in here, and then it gives information about the object that we are watching and all. So similar analogy was used. There are x1, x2, xn inputs are there. So input layer is characteristic of a neural network. Then hidden layer. Now there are many hidden layers, but for the understanding we have used one hidden layer only. And then output can be also be more than one, depending on the problem in question actually. And then each input has got some weights attached with the input. and then accordingly this input. So that means something magical is happening at the node, which is building the network and giving signal to the next node, and output is generated. So everything is happening between input layer, hidden layer and output layer. Just for the information, nowadays more than one hidden layer, because a lot of insights are available at this stage itself, and the output is there. So this is what we have, this is what the architecture is there, and the inspiration that we have discussed over here. So what is happening at the node in ANN? So at the core of it, it is a activation function. This I am showing a sigmoid activation function. If there is some input and then a node can have more than one inputs. So they are all summation in a fashion, and then the activation function is simulated, and it can range from 0 to 1. Okay, and when it reaches 1, the training is done, the node is matured. Okay. So this is a node in artificial neural network. Input connection, output is 1 only from each node. And then what it does basically, learning, memory and stability. Supervised learning, input are given, output is given, what should be the input for which vector, it is mapped over there, and the neural network is trained. So the training power is there with the node actually. Okay. And then it has got memory, learning. So the biggest advantage is artificial neural network. You train it for certain task and it will learn, and now you would have seen many examples here. And then for repetitive task, at least it can replace the humans, which are very routine in nature and things like that. And the activation functions, there are a host of, I have concluded, I have got few activation function. This is a input, it will give 0 or 1 this thing, and then this function exhibits a discrete empty property, property. That means discrete properties actually, 0 or 1. Sign is fx minus 1 to plus 1, and then this also has got like a step mode only, but it ranges from plus 1 to minus 1. Fx is the function, x is the parameter input. Sign activation can be used to map to binary outputs at prediction time. Its non-differentiability prevents its use for, so since it is it can be between minus 1 plus 1 that value. So definitely for certain application it is very useful where you require a binary characteristic. Okay, but for other things it may not be useful. So we have this identity function, fx is equal to x, and then it is implemented like this, from 0 to 1 and minus 1 and x1. Identity is a linear activation function. In fact, it can be said that it is very close to the any mathematical problem, but with some complexity in terms of defining the parameter, and that is where the artificial neural network ML algorithm they come into picture. The sigmoid function, what is happening to the at the node, you can see this is the sigmoid function, 1 upon 1 plus e raised to power minus x. Minus x is nothing but net of summation of all the inputs that you have along with its weight. So multiply by weight, have the input, multiply by weight, it will become a net function or x, and here it is evolved, and then output will be generated. So it is from 0 to 1. Sigmoid function was very popular at certain stages, but then now we have more function hyper tangent. Again it has got, it is like sigma function only, but it varies from minus 1 to plus 1. Same way we have a ReLU function. ReLU function is also like a linear function, but it is extensively used for regeneration and things like that, or classification, and this is one of the preferred function data engineering and choice of a hidden layer. So when it is at the hidden layer, it really gives a very useful insights, because this a node works at the hidden layer also, it works at the output layer also, it works at the input layer also. Processing happen at the input layer, hidden layer, a partial processing, and some insights can be had from the neural network. It can be recorded and can be analyzed, and then hypertangent function has been claimed to work in almost always better than sigmoid. So it has been shown to be superior because it has got variation from +1 to -1, and sigmoid has 0 to 1, and it is operating on the upper this positive domain only. So like that, and then we have a unsupervised support vector machine. As I had mentioned, in a population, we have huge data set, and now manually if we do, it is a impossible task. But then if we choose, or if we choose some vectors like here defined as Wx minus b, W is the distance between the data point and this line that is drawn over here. So this particular mechanism, but then for this we need two attributes, x1 and x2. So these two attributes on which the line is built, and it has got a form Wx minus b, and we can have the, based on the distance we can have. So you can say here it is 1, here it is, so it is a positive domain, it is a negative domain, and that's why two data sets we were able to identify. So in perpetuity forming on a huge database, this kind of exercise, and we have a set of data sharing similar characteristic, and that is how this support vector machine, it is very popular thing, because from the it is the major challenge as on today is classifying and categorizing the data, which a support machine provides a very elegant mechanism. We have to define an acceptance criteria, and SVM algorithm is popular supervised learning, unsupervised learning. See, we didn't have any vector which is telling us what I want, but the mechanism, built-in mechanism itself categorizes the data sets from one to another. So in this week we have started introduction to the artificial intelligence, and we know that R&D field is inspired from human artificial intelligence, machine learning and all that we have done, and then we have seen up to neural network, activation function and support vector machine. Next lecture will take regression, gradient descent optimization, genetic algorithm, and I think decision tree, and this thing is not there actually. So, and then reinforced learning, this we have actually. But then these two tools also, they will keep coming in the future when we have a problem which needs this kind of tool. So there is a sequential probability ratio test, SPRT techniques. There are many techniques that are there. As and when it comes, we will be discussing those things. In next lecture, we will see these are the things that I have listed over here.